Hey, this is Joe Burnett on the Runner team. I'd like to introduce you to Step Runner. We just finished the first iteration, Bootstrapping, which gets the Step Runner binary into a canonical repository, gets it set up with tests, and introduces the most basic syntax that you can actually use to build stuff. It's actually something that you could use in GitLab.com right now, and I'm going to show you how that works. I want to show you what the syntax is. I want to show you how to invoke steps. I want to show you how to define them. I'm going to show you what the basic data structures are that you write in the YAML, and also the expressions that you can use to program it. And I'm going to give you a couple examples because really Step Runner is building material. We have been programming in YAML for ages, and it's kind of like, sometimes it's like, working with one hand behind your back because you know how all the usual programming tools. So Step Runner is moving towards getting more of those things that you need for any programming language. And so sort of as a way to test it, I did a little bit of hacking over the last couple of days to try to use it to build something interesting. And I'm going to show you what I built. It's the ability to have a sort of a proof of concept for running GitHub Actions inside of a Step, and also for running things inside containers. And I've demonstrated this a little bit before, but I think it was previously kind of coupled to Step Runner. This is entirely outside. So again, what we've been doing with Step Runner is really paring it down to the minimum core necessary to serve as this building material so we can construct all the other parts on the outside. It really allows it to be quite pluggable, quite versatile, and have a stable core. And then I'm going to talk to you a little bit about what the benefits are of Step Runner besides the programming and composability aspect of it. There's quite a few other things that it does for GitLab Runner, and tell you what you could do about it, what you could do with it, and what you can do to follow up. So yeah, bootstrapping. We got this repository set up. It's here. It's under gitlab.com, gitlab.org, Step Runner. And it's got a pipeline set up. It does unit tests, has a little integration test, even has an end-to-end test, builds the Docker, a Docker container and pushes it. And this is what you can use to run it in production. I'm going to show you a little bit about how to use this. So there's a little how-to I wrote here. And it kind of just goes through the basic syntax. This is what it looks like to use a step. Okay, so a step is one piece of a job, right? You sort of takes a whole job and composes it, makes it a composition of these individual steps. So you have a name for it, of course. You have the pointer, a reference to that step. And in this case, it's a remote reference. You can have local references, you can have other kinds of references, but this one is over HTTP, do a git pull on this step. And there's other things you can add here, like, a hash, a tag, etc., and give it these inputs. So we've really kind of tried to define inputs, outputs very explicitly, very much like a function call. So I'm going to use a lot of language analogies because I think that's the right way to think about this. These are the function arguments, okay? Now, the function definition itself has two parts. One is this spec. Think about this as like the function signature, right? It tells you what the inputs and outputs are going to be. The type gives it defaults if you want, etc. Then the actual definition is like the function body. And there's only two kinds right now. One is exec, and that's going to literally just exec something. Okay, and that's by itself, that's not a lot, but combined with expressions and interpolation, that actually really unlocks a lot of powerful use cases. I'm going to show you how that comes together. The second type is called steps. And it's actually the same syntax as the invocation. So just like in a function, you can call other functions, you can sort of take a chunk of code, package it together, put an interface on it. It's an abstraction. So that's what GitHub calls composite steps. How do you actually use this on gitlab.com? Well, here's an example. This is the V0 reference. This is just updated continuously if the tests pass. So of course, this is like an experimental phase, so please try it out. But like this reference here should indicate to you that this is pre-beta. Yeah, and what it is inside of here, we've taken step runner, stuck it in there, and there's just one command, CI, and it looks for an environment variable. So this is just a little hack we did to sort of allow you to get the steps in here. One of the next iterations is going to bootstrap the syntax into GitLab Rails and also runner, so that we don't need to put it in an environment variable. That's not the long-term plan. It's supposed to be like a first-class part of the CI syntax. Anyway, you put these steps in here. This just means it's a string. So just a YAML list of steps, however many you want. And then typically I try to capture this one output file, the step results, which just kind of shows you a trace of exactly what it did and what happened, which is very useful. And speaking of that, that JSON, it's all defined in a protocol buffer. So when I say proto, I mean protocol buffers. And protocol buffers are a binary definition of the data structure. There's also a text representation, but primarily it's used for binary, for serialization. And this is meant to be sort of the real stable core of steps, okay? And right now there's a one-to-one mapping between the proto and what you write in the invocation itself and these definitions. However, we're going to add a little bit of sugar because things get a little bit verbose. And you'll see that in my examples, because right now I'm just using that core syntax. But that's okay, because it all comes back down to the core. So in the proto, you just have, the step, the definition, the spec. So this is like the invocation, the implementation, the interface, just the two combined. You have inputs, types, and you have the result. And the result is going to kind of give you that definition, tell you a few things about what happened, environment variables that were exported, outputs that were put out, and exit code and children's steps. So exports, environment variables are like globals, basically. Not the best way to do things, but sometimes you need them. Children's steps are because these steps can be composite, right? They can be, unfold into multiple additional steps. And so the results are also recursive in this way. There's a very recursive structure to this, and I'll show you again how that plays into runner integration. Yeah, so there's really two languages here. The YAML sort of and proto sort of define this basic like steps language, but then there's the expressions, and the expressions are a very important part. The expression syntax right now is very basic. It's just a single reference to a single piece of data. You just grab something and stick it in there. But it's going to be more complex than that, where that's one of the biggest, that's what we're going to work on our third iteration, is adding more to this. If statements, filters, like this is where you would want sort of like a very optimized inline sort of functional language for taking data and transforming it so that, combined with the steps language, you can get, pretty flexible definition of a job or the steps. So right now what you can do is you can reference the inputs that you've gotten. So like in a step definition, you can get the inputs, of course. You can always reference the environment because they're globals. You can get outputs from previous steps. So this is only available in the higher level invocation of the steps below it, right? Because this is using the return values of your previous invocations. You won't be able to do that from the implementation, of course, because you can't from a function reach up into your higher level context and take something out of there. You shouldn't. So we're not allowing that. These are all the places that you can put it, which is pretty much everywhere there's a value, except for, of course, the function interface, the spec itself, and not in defaults, because those are in the spec, right? Yeah. So that's what expressions look like. You can see they've just got this little curly thing, pretty straightforward. Yeah, Yeah. So now I'd like to walk you through a couple of examples. So I've made a repository, hello step runner, and I've defined a couple of examples here, and I want to walk you through what these do. So for starters, I'm going to kick off a workflow just so you can see them run. Just be honest here. So I'm going to run this pipeline. And then I'm going to come back here. And I'm going to walk you through the examples. Okay, what is going on here? Well, there's a couple things. First of all, I added a little something. I added a little something to StepRunner. And what I've done, this is me just like playing with StepRunner. This is what I did over the last two or 3 days to kind of try to see how it is to use. I added a project called Act, which is kind of the most popular way of running GitHub Actions locally. Okay, and I folded it into StepRunner. So if I could come here and I look at steps, here is, my image definition. I just took this same StepRunner that I've been pointing you to, and I basically pulled in the Go code that defines the steps, and I pulled down Act and stuck it in the container. So when you see, this container, it's just adding Act into the environment. I also am providing the Docker host because Act actually uses Docker to run the actions. And so, that's the way that you do that in GitHub is you need this service that goes on the side. And then I provide my steps. I'm going to walk you through these. So step number one, it's just a bash script. So it uses steps bash. I didn't show you that one. So let me come back here and show you my local steps. You'll notice that this is using that local invocation, that local reference. And bash is just this. It just execs bash and just runs your thing. So it's like the simplest step you could really do. We're going to have some sugar for this. Like we can take this script and bring it up to be a top level value, have it point to something that can automatically detect which shell you want to run, and just make it a little easier. That's part of the sugar that I was talking about, but ultimately it'll fold back down to this. So I just echo this. This is the way we output, key equals value to this file. That's pretty much it. There's StepRunner output and StepRunner environment. There's StepRunner env. And those are where every single invocation gets, files where it's supposed to drop the outputs. Because this is a super polyglot like language, right? Like every one of these steps could be anything, right? It could be a shell script, it could be a whole bunch of other things. It doesn't, you have no idea. So we just need a way of getting data in and out. The second one here, so all I did is I said my favorite AWS region happens to be US East 2. That's where all the Macs are. So region reduction. This is like left pad of actions. I just went to the actions marketplace and like grabbed 2 random ones to try out here. This basically takes a region and gives you the short version. And so I want the fixed format. And I'm just using this as a way to show you how the inputs get in and out. So here I referenced this previous step from my favorite AWS region, right? That's the name of this step, and getting the output AWS region. This cat step, I should show you this. I should show you what it does. This is just act in a container. So I just rearranged the letters. Here we go. And it's actually a Go program because it was a little bit more complicated. But you can see I've defined the inputs. And here, in this main Go file, so the step is say, go run this thing. So when you pull down the step, we get that step definition, but we also get all the other payload of files around it too. So you can delegate to, with that exec, you could delegate to something else. And in this case, I'm delegating to this little function. And the way that I've shimmed act in here is I make a little single action workflow, right? And I write it to a file. And then I call act and I say, hey, here's my workflow, run this job, use this. This is like one of the images that people use locally. And then just grab the output and parse the outputs, right? Because a lot of these actions like print to standard out with a special format in order to output, but that's not what StepRunner is expecting. So we just translate that into the actual StepRunner output file and then give the logs. So that's all that cat is doing. And it has has that container so it can have the right environment to use act. So, yeah, and then when I greet the region, I actually reference the output from this GitHub action, outputs results. And so this shows you how you can use a combination of steps and actions, local and remote, because actually this one right here is a remote step. It's just an echo step that we use for testing, and it just echoes you back whatever you say. So it just says hello result. That's example one. Let's actually go see if it ran. It did. Not a surprise, but so it says hello UE2. I didn't actually know that was the shorthand version for USA's2, but now I do. Thank you very much, Cloud Posse. All right. Great. So that's like I said, that's a pretty simple one. Let's do something a little bit harder. This follows the same pattern as the one before, so it's not too much at the same time. Here, I'm just saying, scanning image. And I grabbed this random action here, image scan. It scans a Docker image and tells you if there's any vulnerabilities. And here this is the image to scan. I'm just scanning the StepRunner image, I guess. And fail on critical, and I have a few to ignore. And then afterwards it says image is secure. If it's not secure, it'll fail. It won't get to that point. So this does the same thing. So here, it ran. So you can see it gave a lot of output, blah, blah, blah. Scanning image. I just kind of dumped the logs just because it's nice to see what's going on. And Act actually did quite a bit here. It did a Docker pull and ran the thing in that container, that one that I was, the Cat the Hacker image that I was pointing at. And ultimately it says this is good to go. Now I wanted to show you the trace too while I'm here actually. So I can click on browse. Remember I made this an artifact, and I can pull up the actual trace, and you can see there's the definition of the step. This is the, all it did is it took my steps that I wrote in CI and it just slapped a no op spec on top. This is something kind of interesting to pay attention to. And then these are the results. It's got the definition that it pulled from the either the remote repository step YAML or the step YAML in the local file. It shows you, like what the inputs were. Shows you should be outputs here too. Inputs. Okay. Well, I don't know what else. There's a few things that are missing from the trace, especially with some of the experimenting I was doing didn't get the whole trace in there. And I'm going to talk to you more about why and what's going to happen with that. So we'll put a pin in that for now. Yeah, so that's this right here. This is great, but as you can see, this is pretty verbose, right? Like there's a lot going on here. having to do all this to say before and just something before and after is kind of annoying. I talked a little bit about sugar, but it won't solve all of this. Also, there's something here. I don't know if you noticed this or not, but there's like inputs. What's up with that? All of the environment variables and outputs are strings, right? It's just very simple. But the inputs can be an arbitrary structure. So if you look at the actual proto here, inputs can be Google protobuf value, which is really just a protobuf version of JSON. And we want to have deep, complex inputs for delegation. So in this case, what I'm actually doing is I'm saying, okay, here's the actual inputs that I want. I want all of these inputs to get shoved into this step. It'll make more sense when I show you how Docker run and how other delegations work later. Just take it for now that we have complex inputs, okay? So what happens if we want to sort of encapsulate this? Let's abstract this, okay? Let's put it into just a simple step. So I made a step called scan image. And you'll notice that this is actually a lot nicer of an invocation, right? It says name, scan image, the step, and the inputs. And I renamed this to what I want it to be. I removed some of the other inputs, which I just said, of course, it's going to be critical only. Let me show you what the definition of that is. So when I do scan image, look at that. It's just exactly what we had before. I just stuck it in a step, and I parameterized the parts that I want to make free variables. Image, known CVEs. I can even give them defaults if I want. This is function abstraction, like we're used to, right? This is what you want when you're programming. This is how you keep complexity down. This is how you get reuse and composability. Yeah. So example 3, you kind of already saw it. No surprise, it passed. I made sure it passed before we did this video. It does exactly the same thing, right? Precisely the same thing. Except if you actually look at the step results, the trace of what happened, the definition's much smaller, right? Because it's just one step, right? And now it has children steps because it actually went down one level here, and that has all those 3 inner, like lower level steps were captured in children. And of course, children can have children recursively. So that is, that's kind of what it's like to use. This is just a proof of concept of what it's like to use GitHub Actions in your normal workflow, how to abstract them. You'll notice that like this step right here, it doesn't say anything about actions. It doesn't say anything about like the implementation. You could just use this and change it just like you could any other function. That's the purpose of abstraction, to sort of have a boundary of understanding and a boundary of responsibility. Okay, great. Example 4. I didn't get this one working in CI, but it does work locally. So I'm actually going to jump over to the command line here real quick. There we go. All right, so this is the same, CI YAML that we were working on. And I wrote a little hack here. And just to show you what it looks like, this is example 1. Well, notice that I'm actually running this locally. And that's pretty cool, actually. My little hack script just pulls out the steps. It just goes in here and uses, it just uses YQ to just pull out the steps. Running locally. This is really powerful when you can get the thing working, right? Like you can see, this is what you want for programming. You want to be able to reproduce it locally. You want to be able to step through it. You want to be able to really get your hands on it in order to figure out what's wrong and in order to develop on it. This is only half the story for local workflows, jobs, steps, because there's a lot of context that comes from GitLab Rails. But the next thing to do here is we'll call out to GitHub or to GitLab and get, like the fully expanded workflow definition, and then we can do the same thing and just run the steps. A big part of the vision of Step Runner is it's this thing that you can download and use locally, and it is exactly the same thing that is used in production, right? It's exactly the same binary that actually runs all the jobs. So it lets you like really not worry, like it just removes a whole class of problems of trying to keep pace like with what actually happens in production. Like Act, running actions locally, has done a tremendous amount of work to try to be mostly compatible with GitHub Actions, but it's always this game of catch up, and there's always gaps. The other thing we've done is we tried to make everything as hermetic as possible. You have to define your inputs, define your outputs, like everything's captured. So like it's a very, it helps with local running. Anyway, so that's running locally. I'm going to run a number 4, example 4. And I want to walk you through what this thing is actually doing. So I'm just going to run it over there in the background. Now look at this. This is kind of interesting. Remember how I put Act into the environment? Eventually, Step Runner doesn't necessarily need to be in a container when you use it in production. Well, eventually we'll just put this on all of our shared machines. It's just a single Golang binary. It's meant to be in the environment. So you don't have to use, you don't have to run this specific image. You could just run your own image. But that it introduces an interesting dilemma. Like, well, what happens if you want other things to be available for certain steps? Like running actions, you want Act. Well, you can just run those steps in a Docker container, right? Just specific steps or subsets of the steps can be run in a Docker container. And so I've created this steps Docker run. Let's take a look at what this thing actually is. Again, it was a little bit complicated for just a flat exec with without anything else. So I put it in a Golang binary. It only got that way because I had to deal with detecting Docker host, and sort of like this was me trying to get it to work in CI. I didn't need that when I don't really need it when I run it locally. But all it really comes down to is just running Docker. It just says, give me an image, give me the steps, and give me the job directory, like where to do it. So this is where deep inputs are really valuable. So let's see here, steps. So notice I just pass the steps as a variable. It just becomes like a JSON blob. Okay. And this is really important because those steps just get executed by a step runner inside the Docker container. So there's this step runner outside, right? And it says, okay, you want to run this, you want to run this step. Great. Here's one input. The image is what image to actually run, right? I included a couple other hacks in there because I was trying to get this thing to work. And the other input is steps, and it's a deep input. And so when it actually executes, right, notice that it actually runs step runner inside the container and just, again, gives it a whole nother set of steps to run, just like we originally invoked this one. So it looks exactly the same. And then this step runner inside the Docker container just goes and does the thing. Like it'll pull down the steps that it needs to do the thing and then write the results. So ultimately what we've done here is we've taken scan image and run it inside a container that has Act in this, alongside actually this one, which doesn't. So, and it works. You can see here. Yeah, so that's what it's going to be like to run steps in containers. Now notice that it's actually entirely external to StepRunner. Like I was saying, StepRunner's building material. So GitLab will actually have a canonical set of steps that we build for you to do a lot of this stuff that you're going to use. There's going to be steps for running something in a Docker container. And this also decouples that development from everything else so that we can move independently, move more quickly to keep the complexity down, etc. So this will have a way for you to run something in a Docker image that could easily be extended to running something in a VM or running something remotely, as you could see. Like it's like runner executing these steps in step runner in some remote environment is exactly the same thing. When I was telling you that we don't get the whole trace, it's because we don't really have a way to pull all that data back out of the container right now. You know, it's just a simple like exec here, but we will. And I think the current plan is probably to have a gRPC service on a socket, and that service will allow you to connect to StepRunner, give it something to run, get that binary payload back, and then fold that into the higher level context. So eventually, even if all these pieces are executed in containers and different places, all those will come back up as that proto and get expanded into the complete view of exactly how that job was run. Yeah. So the stable proto is pretty cool for reproducibility, debuggability. We also are targeting like making it, like binary compatible. So we're going to capture the, Git repository hash that was used. We're going to have a mechanism for steps to be able to intentionally be deterministic. Like if your step is pull master and build it, that's not going to be the same every time. So we will provide previous outputs. And I have a merge request out right now that implements a replay command, which takes actually the results and runs them back through StepRunner again to verify that it produces exactly the same results. And it does just that. It just takes the outputs and it feeds them back in. So if you have a git clone step, you need to you clone the tag you want, output the hash as an output. And then when you run again, if you have the previous output, check out that commit, to make it reproducible. So like this allows, steps to be deterministic. Yeah, so I've showed you quite a bit already. I showed you the basic data structure. I showed you the little bit of the expressions. What I was able to hack up, which was this, sort of scanning an image with an action in a container, just something kind of fun to try. I'd like to talk to you a little bit about like, what does this actually do for a runner? Because what you've seen so far is actually a pretty independent project. So I've already talked about composition and reusability. So that's useful for the overall workflow. But it also puts an agent inside of the execution environment. So this will effectively replace the whole scripts folder of runner, the abstract shell or abstract script, all the different PowerShell, etc. Instead of like building a shell script in one environment and executing in another, this is going to replace that because it's just going to take this very simple payload, send it straight across without modification into the environment, and it will be able to just build it for that environment in that environment. It also gives you an option for reconnecting. So like I was saying, there's this gRPC mechanism we're going to use, and you can reconnect to an existing running step or a series of steps and sort of pick up where you left off or stream the logs or whatever. So this actually is a step towards making GitLab Runner more stateless, so that like if runner reboots or if you have to update it, we can actually now build a mechanism to reattach to running jobs without stopping them. I was also telling you about how it helps with local execution, which is great. Helps with compatibility. And the stable proto is it's a little bit like the compiled version of these workflows. It's good for migration too. Like if you have some other workflow system and you want to migrate it, you translate it into that proto and you write this binary file, and that won't change. Even if the sugar and context change, et cetera, like you've got this stable, backwards compatible binary blob that describes exactly what to do. So yeah, it's going to help with migrating things to GitLab Runner as well. Yeah, those are some of the benefits. Yeah, it's pretty cool, I think. So yeah, what I'd like you to do is I'd like you to try it out. Just kind of you have my hello step runner there to look at as an example. Try to do something unexpected with it. Try to just see if you can get it to, like, I don't know, run PowerShell, or maybe if you can get it to run Docker container in CI. I couldn't do it yet, but and then I'm going to give you a feedback issue. I want you to tell me what you did. What did you try? Were you able to get something working? Show me, and I'll take a look at it. What was annoying? Like, what was hard to figure out? What did you run into? Like, for example, I had to write a whole Go program to run a Docker run because I didn't quite have enough power with the YAML and the expressions to handle if Docker host or not. So I had to write a Go binary. That was kind of annoying. Tell me stuff like that. It's an experiment. I'm sure you'll run into bugs, report them, fix them. It's a pretty new project, so it's pretty easy to engage with. There's not a lot of code, and the pipeline right now is super fast. And then follow the viable epics. So in the description of this video, I will link, the feedback issue, the repository code, and also the epics to follow, so that we've defined what work needs to happen to make this SEP runner viable as a product, and then other subsequent stages as well. So yeah, just follow the viable one, and that will sort of help you see when it's fully integrated into runner, when it gets into a beta stage, and when you can start using it in your production workflows. So thanks for watching. I hope that you enjoyed hearing about StepRunner. I hope that you poke at it a little bit. I hope you contribute to it. And I hope ultimately it makes your workflows easier to use, more fun to use, and lets us do more with less. So thanks.